That quiz should be done by Friday. And I just thought I would take today to answer any questions on the review or on any other past homework assignments from chapter 5. So if you have a question, you can either unmute yourself and ask, or you could put it in the chat.
Could you go over number 40? I'm not sure if it wasn't sure how to do it because it's like sine x and 1, and I wasn't sure which was the high interval and which was the low interval.
Okay, so number 40 on the review.
Yeah, on the review.
Okay, just want to make sure I'm doing the right problem. All right. So if I'm looking at the right problem, and yell at me if it's not. Going from 1 to sine x of 1 minus t squared over 1 plus t to the 4th dt. And we want to find the derivative. So this is g of x. We want to find g prime. So, excuse me. We always want, if we define a function by an integral, we always want our variable as our upper limit. So that is the way I want that set. The process then is to take the upper limit and plug it in everywhere you see a variable in the integrand. So we'd go 1 minus sine squared t over 1 plus sine to the 4th t. I'm sorry. It should be x's now, because it's an x in the limit. But then, because this is a function, it basically acts as a chain rule. And we would need to multiply by the derivative of sine x, which is cosine x. And so that would be one way to write the answer, and that would be perfectly acceptable. There are a couple other ways you could write this, because 1 minus sine x is cosine squared, I'm sorry, excuse me, 1 minus sine squared x is the same as cosine squared x. And I'm not sure how the book answer key listed it, but this is another possible answer. This is fine right here. Again, on the multiple choice section of the AP exam, you might see this an answer in that version, and just being able to understand how to get to that is important. Does that answer your question?
Yeah, I didn't realize I needed to do the times cosine chain rule
Yep.
thing.
Yep. So, if you think about it, what's happening is when you do the integral, so g of x is some big function, and it's evaluated at sine x minus whatever that big function is evaluated at 1. So when you take the derivative, you take the derivative at f evaluated at sine, and as I said, this becomes a chain rule. So then you would multiply that by the derivative of sine, which is cosine. And the derivative of capital F of 1, well, capital F of 1 is just a constant. So it becomes 0 when you take the derivative. I don't know if that's more helpful or less helpful. But this, so I'll just write one more thing here where capital F prime is 1 plus t squared. Nope. Helps if I write it the right way. And 1 plus t to the 4th. So again, that's what's going on there. Anytime you're using the fundamental theorem of calculus. Other questions? All right, well, you have your, from the chat. 5.3. Yeah, we can certainly look at questions from 5.3 now. That's fine. I'm more than willing. So 5.3, number 22 on page 363. Evaluate the integral. The integral goes from 0 to 1 of 4 over t squared plus 1 dt. All right. So a couple of things, and we'll talk a little more about this at the end of the week. Whoa, that was cool. Anytime I have variables that are just in the denominator, and nowhere else, that tells me that I'm going to have one of maybe 3 different possible integrals. And so if you think about what functions create fractions when you take their derivatives, there are 4 that we talked about. 4. LNs, natural logs, and then the inverse, cosine, sine, and tangent. So anytime I see a situation where my derivative, try that again, where my integrand has variables only in the denominator, I'm pretty sure that I'm going to have one of those 4 functions as my integral. So what I would do here, this 4, I can write out front. And 1 over, and we usually wrote it the other way. We usually wrote it 1 over 1 plus t squared. But that's inverse tangent. And we're going to evaluate that from 0 to 1. So we're going to take the inverse tangent at 1 minus the inverse tangent at 0. And now I have to think about this. Inverse tangent at 1 is pi over 4. And inverse tangent at 0 is 0. So pi would be our answer. And so just as a reminder, on page 358, there is that list of integrals that we will definitely want to make sure we have memorized. And the more we work with them, the more they'll be committed to memory, just like our work with derivatives. All right. Question answered, I hope. Any other questions? All right. Then I'm going to stay on. If you want to ask questions, you certainly can. Otherwise, you have that the quiz to work on, and then we'll start chapter 5, section 5 on Friday. All sorts of fun coming up with integrals.